Hello and welcome to today's webinar in partnership with Constantia Flexibles, hosted by Packaging Europe. In today's webinar, our speakers from Constantia Flexibles, Nespresso and Spira will explore the benefits of using aluminium in flexible packaging, with a special focus on recycled content, sustainable sourcing and low-carbon aluminium. They'll also take a look ahead at what's next for the industry. So my name is Elisabeth Skoda. I'm one of the editors of Packaging Europe. For those of you who are unfamiliar with Packaging Europe, we are the leading intelligence resource for European packaging professionals. Via our magazine and website, as well as our online and in-person events such as the Sustainability Awards and Sustainable Packaging Summit, we deliver daily news content, authoritative comment and analysis, case studies, and high-profile interviews with leading industry players, and we enable communication across the packaging value chain. So for today's webinar, I'm very pleased to be joined by Dr. Martin Kornfeld, who is Vice President of the R&D Competence Center for Aluminium at Constantia Flexibles. We also have Marianne Neumüller-Klapper, who is Operations and Sustainability Director at Nestlé Nespresso. And last but not least, we have Seamus Donovan, who is Head of Sustainability and Environment at Spira. Today, we'll start this webinar with Constantia Flexibles talking about the key features and advantages of aluminium, highlighting its adaptability as well. Dr. Kornfeld will present innovative, sustainable solutions and showcasing what the material can do. Following that, Nespresso's Marianne Neumüller-Klapper will share the company's experience in becoming more sustainable, especially through using more recycled content. This will deepen your understanding, hopefully, of how aluminium can be part of more sustainable practices. After that, Spira's Seamus Donovan will share his knowledge about extracting aluminium in a sustainable way, and he'll share how low-carbon aluminium can be the next step in sustainable packaging, highlighting the importance of obtaining materials sustainably. And to wrap up, Dr. Kornfeld will talk to us about the potential of low-carbon aluminium. So before we get into the webinar itself, just a little bit of housekeeping. There are 15 minutes at the end of this webinar reserved for a Q&A, and using the chat facility, please direct message us with your questions and we can put them to our presenters at the end of the session. You can do this throughout the entire webinar and we'll endeavour to get as many of your questions answered as possible. For any technical questions, please select the support button, which you will see at the left-hand side of the screen. And for any streaming related issues, you can also use the help button on the bottom right of the stream window. So to get us started with this webinar, some quick information about Constantia Flexibles. The company was founded on the guiding principles of people, passion, packaging, and manufactures tailor-made flexible packaging solutions. With around 7,650 employees, the company is the second biggest flexible packaging producer in Europe and number 3 globally. And it has a worldwide presence with 30 production sites. Its headquarters are in the head of Europe in Austria's capital, Vienna. And Europe is also the company's biggest market, followed by the Americas, Asia Pacific, and Middle East and Africa. It serves the consumer sector, which makes up the major share of its business at 71%, and also the pharmaceutical sector with 29%. And 54% of the company's output is aluminium-based, and 44% of the production share is made up of flexible plastics. Last but not least, there's also paper-based packaging, which is currently at 2%, but growing steadily. So with that, I'd like to hand over to our first speaker, Dr. Martin Kornfeld, to take a deeper look at Constantia Flexibles and aluminium in flexible packaging. Over to you, Martin.
Thank you, Elisabeth, for the nice introduction. It's a pleasure for me to talk today about aluminium, since aluminium is a really great material with very interesting characteristics. And a selection of these characteristics we can see on the next slide. First of all, aluminium has very versatile properties. Yeah, it's lightweight. Yeah, it's a light metal. This means it has a specific weight of 2.7 grams per cubic centimeter, or 2.7 kilograms per liter. And compared to other metals, this is really light. Yeah, for instance, when you compare it to iron, it's about 1/3 of the weight of iron. But however, it's flexible, it's pliable. This means that it's ductile and gives a good formable characteristics. It's durable, yeah, which is also important for many applications, and also it's conductive. And conductive means in terms of heat, yeah, temperature, can pass through the material quite easily, and also electrical conductivity is important for many applications. Then, and this is also very important, it's not a rare element, yeah, it's not a rare metal, the availability is good. When you look at the Earth's crust, it's the third most common material in the Earth's crust, and also to say it's the most common metal in the Earth's crust. And it has excellent properties to be used in many different applications, like, for instance, packaging, that's what we are talking today, construction or automotive. And last but not least, it's very energy efficient, especially when you treat it the right way end of life. This means when you're recycling aluminium, 95% of the energy is saved compared to its primary production. And this is very important, recycling goes without any loss in its material properties. When we look at the properties and the specific advantages for packaging, we can see it on the next slide. First of all, we have perfect barrier properties. We are saying in the packaging industry, the aluminium has total barrier properties, and this goes together with the big advantage of the flavor protection, yeah, because the barrier means that no light can pass through the material, no permeation of gases or moisture will occur, and this gives then perfect protection for the filled foodstuff or pharmaceutical product. It has a very good heat performance. This means that it's temperature resistant, and this is important when it comes to seal applications, for instance. It gives a very tight seal when you seal the material with the required temperatures. And also it has advantages for further treating the filled product, for instance, in the packaging, yeah, for retort or also in household when you heat it up. Recyclability, that's what we already said. Yeah, 95% of the energy or the carbon emissions can be saved by recycling. And the mechanical performance is great. Also, like said, it's lightweight, yeah, but however, it's still strong, it's stiff, yeah, and it has very important or very interesting properties for specific applications. Deadfold, for instance, for wrapping applications, or the push-through properties when it comes to pharmaceutical blister packaging. And also, like said already, it's ductile, you have a good formability, you can produce a lot of different container shapes, yeah, they're stiff, they're very stable, and it's fit for cold forming, which is also a nice feature, or not a nice feature, a very important feature for pharmaceuticals. And when it comes to barrier and flavor protection, we can say that aluminium packaging preserves food and pharmaceutical products perfectly. And like written on the next slide, it's really a net saver of resources. This means that it normally protects much more resources that it consumes. And this also has been shown in manifold and different life cycle assessment, where it's clear that the environmental impacts of the aluminium packaging are much, much smaller than the impact of the food itself. And therefore, by protecting the food, it's very beneficial for the environment. And this would be now already a perfect moment to hand over to Marianne from Nespresso. But before that, I want to say a very few words about responsible sourcing. And this is on the next slide, please. I think the FSC for the paper industry, it's much better known than ASI, but ASI is the Aluminium Stewardship Initiative. And this initiative was founded in 2012. Constantia Flexibles was a founding member of this initiative, and it really steers and looks at the environmental performance, the sustainability performance of the whole supply chain, from mining till recycling. It sets appropriate standards, and Constantia Teich is already certified for the performance standard of ASI and also for the chain of custody standard. And now I want to hand over to Marianne, showing us the advantages of aluminium in her applications.
Thank you, Martin. So we have something in common, that's the ASI founding members. So like is Constantia Flexible, Nespresso is also one of the founding members of the ASI because we use most commonly known aluminium. So hello, I'm Marianne Neumüller. I'm Operations and Sustainability Director at Nespresso in Austria. And thank you for hosting me. And I will talk about coffee quality and why we use aluminium. Next slide, please. Let's have a look at the journey of the coffee bean from roasting to the cup. So the beans are roasted, and by roasting, CO2 leaves the coffee. It's the so-called degazing process. And when grinding the coffee, the surface is increased and more CO2 is degazing. Then the coffee is put into packaging, either a bag or a capsule consisting of different materials. And then a cup of coffee is prepared to be enjoyed. But let's try to answer the question, what means fresh coffee actually? Coffee is only fresh directly after roasting. So fresh coffee has all the qualities that were in the beans and all the passion that the farmer put into the beans, in planting the beans, is in a fresh coffee. And then with roasting, you can underline the aromas. Or in the worst case, if you do something wrong, you destroy the aromas. But most important, when roasting the coffee, the clock starts ticking. The longer coffee is exposed to oxygen, light, and humidity, the more freshness and quality is lost. So in a nutshell, a loss of freshness is a loss of quality. And this is why the product has to be protected properly. And without sufficient protection, the coffee changes and loses its quality and properties massively. So the aromas, they oxidize, the taste becomes rancid, bitter, stale, flat. And as a consequence, you need more coffee to cover the loss in the cup, but the loss cannot be fully compensated. It just increases the perceived coffee intensity. But on the other hand, the downside is by using more coffee, the total CO2 footprint increases, as approximately 50% of the total CO2 footprint of a cup of coffee is coming from coffee farming. So the more coffee you need, the higher your CO2 footprint. Let's go to the next slide. This loss of quality can be scientifically measured with so-called freshness indicators. So the two most important ones are dimethyl disulfide. This smells like onion, garlic, or burnt rubber. And the second one is methanethiol. This smells like rotten eggs, fishy or cheesy. So it's not a nice smell or taste that you get associated with these two chemical indicators. So if you go to the next slide, please. So with these indicators, we can measure this degazing process. So the more of these indicators can be measured, the higher the degazing and the less the quality. And so what has an impact on the speed of degazing? So with roasting, the process of degazing starts and mass is lost. And if I grind the coffee, more structure is broken up and the degazing is getting faster. So roasting has first an impact and then grinding. The finer I grind the coffee, the more structure is broken up and the degazing is speeding up. Next slide, please. And it also depends how dark the coffee is roasted. So a dark roasted coffee is degazing faster than medium or light roast coffee. So it has an impact how I roast and how I grind the coffee. Then when I go to the next slide, when packing whole beans, there is a significant difference in the presence of these chemical markers for the freshness. By using aluminium layer in the packaging, the coffee can be kept fresh longer. So you see the blue and the red line. This is then paper or plastic composite film packaging. So it goes more or less at the same line straight up. If you use aluminium, and the thicker the aluminium is, the slower the degazing process takes place. So you see here the advantage of using aluminium as an oxygen barrier. When we go to the next slide, when we look at the single serve grinded coffee, the advantage of aluminium capsule over the other types of packagings packaging are obvious. So you see then the 4 types of capsules. On the bottom, you see the Nespresso capsule, which is marked as C4. And you see the Nespresso aluminum capsule, the degazing process is very stable. So first, it's just the oxygen that is by nature in the capsule. This is the degazing, and then it's sealed. So it cannot continue with the degazing. So it stays in the capsule. All the aromas stay there. The coffee is fresh, and not only for 1 year, but even longer. And you see the difference. If you have other packaging materials, the degazing process is speeding up. Yeah? And but next, if you go to the next slide, as a customer, you will not measure these 2 chemical indicators, these chemical markers, but you can see it in the cup. Yeah? If you have fresh coffee, you see that that you have this crema on top of the coffee, very thick crema, and the longer the coffee is open, the less freshness you have. And after 1 year, you see the same coffee looks really different. Yeah, you see a significant difference. So you almost have no crema on the coffee. If we go to the next slide. So this gives you the outline why we think that aluminum is the best protection for coffee. And because we also use the best quality. Here is an example, because we are standing for best in-cup quality. We want the best coffee result in the cup. And on the left side, you see coffee that you get in the supermarkets. You see whole beans, and you have light ones, dark ones, you have broken ones. And on the right side, you see the beans that are used for Nespresso, that before grinding, that you put them into the capsule. And we use the best quality beans. It's all the same size, because you can imagine when you're currently doing Christmas biscuits and you have big ones and small ones and put it into the oven, the small ones will be already dark, and the big biscuits will still not be done. So it's the same with the coffee. So that's why we have the same size of beans that we can evenly roast. And we use only beans without defects. And so it's a very homogeneous material that we put then into the capsule. If you go to the next slide, you can also see that there is a impact on the CO2 footprint. So on the left side, you see the LCA result that was done by Quantis back in 2020 for the Austrian market, comparing the Nespresso system with the full automatic machine and a filter machine, depending also on different recycling rates that were then at this date available. But you can immediately see that the Nespresso system, the machine and the capsule together perform better than the full automatic machine, and even have advantage versus the filter machine, which is, from a customer perspective, if you look at the 3 types of machines in preparation of coffee, not that obvious. But the scientific data prove that it's better to have the capsule and the system with the portion system with Nespresso. And on the right side, it's a very good picture, because the left side, it's difficult to explain to an end consumer, but on the right side, you see the left glass with the coffee is the glass that you need, the beans for 50 cups of a full automatic machine. And on the right, in the right glass, you see the beans that are required for 50 cups out of an espresso machine. So, and if you remember that 50% of the CO2 footprint of a cup of coffee comes from coffee farming, the advantage is obvious. If you go to the next slide, please. And we recycle. So since more than 14 years, we have implemented in Austria a capsule recycling system, because the capsule in Austria, and especially in Europe, is not regarded as packaging. So there is no fee for the system. So we set up this private collection and recycling scheme. And we have more than 2,000 collection points currently in Austria. 39% of the capsules that we sell in Austria are collected. And the aluminum is going to the secondary market. And our capsules are produced with minimum 80% recycled content. And not only the capsules are recycled, but also the coffee ground is used to enrich fertilizer, as oil absorbent, or for furniture application. And with this, I hand over to Seamus. Thank you.
Great. Thanks very much, Marianne. I have to say, admit, maybe I'm only a new coffee drinker, only in the last 2 or 3 years, I think. So you just won a new fan with a bit more details on coffee and how we can keep it fresh. So thanks very much for that. And also thanks to everyone for taking the time to attend the webinar today, and also to our colleagues at Constantia Flexibles, just for the chance to participate and to tell a little bit about Spira, who we are, what we do, and also how we can support different stakeholders and customers with our sustainability focused aluminium for the packaging industry. So in the next 10 minutes or so, I'd just simply like to go through a little bit about Spira, who we are, look a little bit about our long-term sustainability ambitions with respect to decarbonization, and then a little bit more deep into the topic of CO2 footprint for the primary production and the importance that recycled aluminium plays and for the long-term decarbonization of the aluminium value chain. So if you could please switch to the next slide. And yeah, just a couple of key points about Spira in general. So we're a relatively new company in name only. So we've been at our manufacturing sites in Germany and in Norway for a number of years. And in a couple of cases, we have 2 manufacturing sites that are well over 100 years old. So we have a very strong and close-knit relationship to the communities where we work and operate. We have about 5,500 team members within Spira. And the other key point, I guess, I would like to highlight on this slide really is the topic of recycling capacity. So this is from our side, one of the key areas that we're most proud of and have been working on in the past couple of years to increase the overall capacity and also bring in new expertise. So we purchased an aluminium recycling company, Real Alloy, this past April. And we're now working to bring in, the new team members with their technology and experience over the past years to help us on our journey to bring more and more recycled content into, our products and what we can offer to the customers. So in terms of sustainability within Spira, so we've talked about sustainability since the beginning with Spira back in June of 2021, and right from the very beginning, our long-term vision is to be the industry benchmark in sustainability. And of course, I think everyone here is very familiar with sustainability and the broad approach that it has. And we look at different elements such as social management, health and safety, governance issues, etc., of course. But when we look at, the key focus area for our customers and different stakeholders and for Spira in total, it's definitely the element of decarbonization and how we want to reduce our emissions over the long term in the different areas of our operations. So if you could switch to the next slide. I'd just quickly like to highlight to everyone how Spira wants to approach our overall decarbonization journey. And the first thing that we did, and it was mentioned a couple of times, the really important elements of transparency and telling the story correctly. And so what we did is that we put together in consultation with a number of different stakeholders internally and externally, a decarbonization plan that highlights then how we want to do this for each of the 3 greenhouse gas emission scopes. So if we look at the scope 2 emissions from Spira, mainly dealing with electricity consumption, and of course we want to reach zero CO2 emissions for scope 2 by 2035. Scope 1, this is a bit more challenging. So here we're really looking at various technology switches within our production operations, moving away from natural gas and looking at either electrification or the use of hydrogen, for example. So this will take a little bit longer, a bit more complex, as I mentioned. And we see here that by 2040, that this is where we want to reach zero CO2 emissions for scope 1. And then scope 3 emissions, and this is the big one for Spira and also for many here, I would expect that this is a significant portion of our overall greenhouse gas emissions. And also here we work with our suppliers in a number of different capacities, to look for low CO2 aluminium suppliers from primary metal, which I'll touch upon in a couple of minutes. But also working with the scrap market to bring in more recycled content to our operations and products, and looking at our products in total, to work with our customers and also our research and development team to see exactly how we can further develop the products and the alloys that we have to have more recycled content included. So with that, as I said, what I would like to do is really talk a little bit more about the two key areas, or the role that both a primary aluminum play in terms of looking at the CO2 footprint, and also then the important role that recycled aluminum has to play, both for Spira and also then for the overall aluminum industry. So with that, I'd ask for the next slide and talk a little bit about, how does the carbon footprint of primary aluminum develop over the entire value chain. So we've put a bit of a kind of a mapping exercise here on the slide to show exactly what are the key areas and stages of the value chain where the carbon footprint is established with respect to primary aluminum. And as you can see, there's three key areas. So we have the alumina refinery, we have the smelter process, and then also the electricity that is used and for the overall production processes. So these are the three areas where, when the new decarbonization technology comes in, this is where we see then a big opportunity to improve the overall CO2 footprint. And if you switch to the next slide, what we can see is that there's a number of different steps with respect to these three key areas. Yeah, so if we talk about the refining of alumina, within these refinery destinations, of course, you can look at renewable energy and also heat pumps to reduce overall emissions. But the big main process, I guess, is the calcination. And here, due to the high temperatures that are required, a flame is definitely preferred for quality reasons. And therefore, the switch away from natural gas to hydrogen as an alternative fuel is seen as a big opportunity for the decarbonization for the refining operations. Smelter operations, and here this is really looking at the carbon anodes that are releasing the CO2 emissions as results of the direct processes. This has been a very similar technology for a number of decades now, and there is the investigations and the movement towards new technologies such as inert anodes, and these are at the moment at lab scale or implemented in small production facilities, but we need then more time then for the scale up. But it's not always cut and dry with many things I've learned in discussing decarbonization within an operational facility. There's always, one side or two sides to the coin and different advantages and disadvantages. And for example, with inert anodes, you may be able to really reduce some of the CO2 emissions. But on the other side, there is an increase in electricity demand. And then finally, in terms of, the last key step or key session for the high CO2 footprint of primary aluminum, or one of the key elements of the CO2 footprint of primary aluminum, is the electricity supply. And here you have to look and see what is the source of your supply of electricity, what's it based on, and that will give you then the relative CO2 footprint. So in Germany, for example, at the moment, we are quite heavily reliant on fossil fuel power, so brown coal, switching step by step to renewables in the coming years, which will effectively lower the CO2 emissions associated with electricity generation. But at the moment, Germany is, of course, focused on fossil fuel. But then there are other countries and other areas that are focused more towards nuclear and renewables, which then have a different CO2 emission value associated with them. And yeah, so those are the kind of the key focus areas along the value chain for primary aluminum that have the most potential then to reduce the overall CO2 footprint associated with that. If we could switch to the next slide, please. And when we talk about then the low CO2 footprint of aluminium and how it's built up and what actually classified as low carbon aluminium, here there's still some room for discussions or agreement, at the global level, so to speak. There is no one single definition agreed upon, but it's what is maybe kind of visible and becoming more and more, known in the industry is to see that a level of 4 kilograms of CO2 per kilogram of aluminium is typically accepted within the aluminium industry as being low carbon aluminium. But of course, that also has to ensure that it represents the entire value chain, from mine up until the rolling operations within Spira. So for us, it's extremely important, and I go back to the element of transparency, that when we put together our CO2 footprint and put it or associate it with the products that we have, we include each step of the value chain. So there's nothing left out. And this represents then a very clear element of our transparency story and how we will then want to communicate that to different stakeholders. Okay, next slide, please. And then the question comes about also to the recycling element of everything. So I talked a little bit about primary production, and I'll touch a little bit more in a couple of minutes about some of the advantages. But from Spira's side, we really also want to focus strongly on the recycling element of aluminium. And here I go back to what Martin mentioned in the first slide or the second slide. When you look at some of the benefits of recycling, the energy consumption is probably one of the key elements that that we see as well. So recycling of aluminium reduces energy consumption by approximately 95% when compared to primary production. And then, of course, that has an impact on the overall greenhouse gas emissions that are associated with the operations. So again, here, a key element for us in the overall aluminum industry is that recycling really brings about a reduction in overall emissions. Also, too, I think everyone is aware that primary aluminum also is associated with different natural resource issues. So again, more recycled leads to more advantages for biodiversity, lower water use, and less natural resource use, for example. But that being said, there's no clear-cut reasoning why one should be used in place of the other. And this is really where we want to kind of highlight a key element and key message from our side is that on the next slide, you can see that a combination of both using recycled aluminium, so the advantages that it brings, and also the advantages of the low emission primary is a key element then for Spira and the overall market, so to speak. So we have the low CO2 emissions on one side, and then we also have the flexibility and availability of primary on the other. And also too, and I'll go back again to Martin. I don't want to take over all of your slides again, but one of the points you mentioned really is the idea that the recycling of aluminium, it maintains its mechanical structures and properties, and this is extremely important. That we ensure that we can continue to fully recycle the different types of aluminium, but still to maintain the quality that we have for the different products. And secondly, it's mentioned here on the slide as well, in that the limited availability of scrap. So here we see in the marketplace that the scrap availability is limited in different areas, and we want to work with customers and stakeholders to bring about increase the closed loop aspect of aluminium recycling. So here we're looking for partners to look at this separation and sorting of scraps to alloys, and to also different categories such as lacquering or laminated scrap or even plain scrap, that we can bring those different sorted scrap sources into our production facilities, bring them into the end products, which of course lowers the overall CO2 footprint of our products, but at the same time is able to then to maintain the mechanical properties that it had in the previous times. So as I mentioned, there's no real kind of yes and no for both, but we see that the approach to take the advantages of the recycled aluminium plus with the low emission primary is a key element that we can use then to support the overall decarbonization across Spira's value chain, but also for the aluminium value chain. So with that, I'll turn it back over to Martin, and we can carry on. Thank you.
Thank you, Seamus. So we have heard now a lot about the advantages of aluminium as a packaging material, about the properties of aluminium, about energy consumption and carbon emissions. And I want to continue now with two questions, which are maybe a little bit rhetorical. Yeah. So First question, would you like to meet your greenhouse gas emission reduction targets? Most probably yes. And would you like to mitigate the consequences of increasing carbon taxes? And this all without making any major adjustments to your packaging lines, or even with no changes to the adjustments. And the solution is available, and this solution is low carbon aluminium. Yeah, and let us now have a look how this can work. So next slide, please. And this now, basically, Shamus has already explained this very, very good and very in detail, but I think it's once again very important to understand, where the carbon emissions are coming from in order to understand what low carbon aluminium really is. And this illustration here from the Aluminium Institute, I think, gives a very good overview. It shows the value chain of aluminium from mining till recycling by the end of the day. And it also shows where the carbon emission occurs. Yeah, it was like Shamus said, for the refining of the alumina, you have a certain input of carbon emissions, and then for sure for the smelting and electrolysis. And next slide, please. If we are going now for the electrolysis to renewable energy, to green energy, we can reduce the carbon emissions for the electrolysis process very, very strongly. And next slide, please. And this is also a possibility. When we bring back the aluminium recycled material, so if you make aluminium recycling and bring it back to the production, we even get rid of the electrolysis. Yeah, and these two possibilities, it's first the usage of green energy, and secondly the usage of a recycled content gives us the possibility to decrease the carbon emissions to a very low value. Next slide, please. And these are the carbon emissions which are typical for the production of 1 ton of aluminium. If you look at the left-hand side, when you are producing the electrolysis energy which is required for the electrolysis just by coil carbon plants, by coil power plants, then we have about 20 tons of carbon dioxide per ton of aluminium. Yeah, this is a very high value. When you look at the European average consumption at the moment, you are at about 8.6. Yeah, and this is mainly from the imports to Europe, which are about 10.6, and the average European production, which is even less at 6.7. And when we go now for green energy for the electrolysis, we can reduce it to 4 kilogram or to 4 tons per ton of aluminium. And once again, if we take recycled content for the production, we will end up at about 0.5 tons per ton of aluminium, which is a huge reduction of the carbon emissions. Next slide, please. What I want to show to you here is now the Constantia Flexibles sustainability roadmap to improve the sustainability performance of our foil-based products. Yeah? And this sustainability roadmap has short-term targets, mid-term targets, and a long-term vision. For the short-term targets, you can see it on the left side. It's down-gauging, it's reducing the amount of used raw materials, and it's also replacing. Yeah, like I said before, it's very important to support recycling. It's also important that our structures are recyclable. And this means that all the structures we currently have, which are not recyclable, like paper foil laminates, for instance, we transform them to recyclable structures. In the middle, in the midterm, it's low carbon aluminium. This was what was described before. Yeah. This is already available, but it has to be brought to the market in huge amounts. And what is also important is to introduce recycled content. And recycled content is already introduced in container materials, in capsule materials, but for thin foil, it's still not available to implement there or to introduce there post-consumer recycled material. It's just post-industrial because the thin foil rolling, this is still a challenge for the recycled aluminium content. And then we have a long-term vision as well. Shamos already explained it, inert anodes or other technologies which further reduce the carbon emissions in the primary production of aluminium. And now I want to show you 3 examples in our product portfolio which fit to this sustainability roadmap and which demonstrate how we are working on that. Next slide, please. First example is our lidding solutions, our die-cut lids, EcoPeel cover and Eco Multi-cover. What does this mean? I said before, according to our sustainability roadmap, it's down-gauging. It's down-gauging the aluminium thickness, and it's also, and this is very important, down-gauging all the other components. Yeah. EcoPeel cover is a co-extrusion specification where we down-gauge the extrusion coating by about 50%. And Eco Multi-cover is a lacquered specification where we also down-gauged the lacquer amount to a very low value. Both specifications are fully recyclable if they are separated from the cups. The appearance stays the same. Yeah, it's the high quality appearance of aluminium, and it's also possible here to use Aluminium Stewardship Initiative certified aluminium. Next slide, please. Eco Alutena, yeah, maybe here the title improve recyclability is not the best one because these containers are perfectly recyclable. The aluminium share is higher than 80%. They are designed for recycling. Down gauging for the aluminium thickness is still done, yeah, and this means that we can down gauge the material without compromising the stability of the containers to a certain limit for sure. We are implementing recycled content toward the aluminium, and like for the die-cut lids, ASI certified aluminium is possible. Next slide, please. This is what also is part of our sustainability roadmap. I said before, it's the substitution or the transformation of non-recyclable structures to recyclable structures, like here the alu paper laminates, which are normally used for wrapping applications on the market. We have developed here a specification, which is a laminate of foil to foil with specific foil properties. And this gives perfect machinability, perfect folding on the packaging lines. The product protection is outstanding because of the foil appearance is great, high quality appearance of the foil, and the recyclability is given. Yeah, this means this is a typical transformation of a non-recyclable structure to a recyclable structure with all the benefits which we are used from aluminium. And next slide, please. And I think these 3 examples showed quite well how we perform and how the sustainability roadmap of Constantia Flexibles is turned into reality with our short-term view, with our mid-term view, and with our long-term vision. And with this, I want to thank you and forward back to Elisabeth.
Yes, thank you, Martin, and thank you, Marianne, and Seamus as well for really interesting presentations and sharing your insights on aluminium. There's definitely a lot to learn there. So yeah, now it's time to move to the Q&A section of this session. We've already had some great questions come through, but obviously continue to send them. If we don't manage to get through all of your questions, I'm sure the team will be happy to follow up with you individually after the session. So I'd like to start with a question for you, Martin, which is low carbon aluminium available now for flexible foil?
Yes, low carbon aluminium is available for flexible foil. And like I explained before, if it comes to thin gauges of foil, it's basically based on green electricity, on renewable electricity, but low carbon aluminium is available and we will be happy to use it in larger quantities.
Thank you, Martin. And you mentioned that, somebody's asking, you mentioned that one of the main benefits of aluminium is being recyclable and thus a valuable material for the circular economy. But the person makes the point that paper and plastics are also recyclable. And the question is, what are the main differences between aluminium and all of these other materials?
Now, aluminium has the big advantage when you recycle aluminium, and that's what was Seamus also pointed out. You have to take care a little bit on the alloys and that it fits together. But basically, you can recycle it, and you do not have a loss in its properties. Yeah, aluminium will perform the same like before. And this is a little bit different to paper and plastics, because for paper and plastics you have a certain degradation, in the paper fiber length and also for the plastics. And you have the big advantage that with regards to food contact compliance, recycled aluminium is always fine. Yeah. So because all the other components which are on the aluminium, they will not alter the material during recycling, and aluminium will have its full food contact compliance afterwards as well.
Thank you, Martin. And another question for you. How can you recycle aluminium in laminated foil, in brackets, triplex?
Yeah, this is a challenge. Yeah, so basically the separation works. Yeah, because with eddy current and technologies like this, it can be separated. Recycling, it can be done by pyrolysis. Yeah, that you pyrolyze the films, for instance, and get some pyrolysis oils and the aluminium back. But basically, if the aluminium has not a certain thickness, it's not the best option. Yeah, and this is also the reason why we transform these laminate structures to monomaterials or to foil laminates, or in certain cases also to foil-free laminates for sure, if this is the better fit. Yeah, but triplex laminates is a challenge. Yeah, and therefore they are transformed.
Thank you, Martin. And I'll put a couple of questions to Marianne now. Somebody's asking, are capsules recycled in regular recycling centres across Europe, or do they need specialised recycling collections?
So here I can say it depends. So the recycling infrastructure in across Europe is quite different. It depends on which sorting center you deliver the material. So, for example, in Germany, when you put it into the yellow bin, it's recycled. When you in Austria, the capsule, it's not regarded as, it's not classified as packaging, so it's still a product. We have a voluntary option that we enter the yellow-blue bin in Vienna, city of Vienna, for example. It's sorted, yeah, but it really depends on the sorting center. It doesn't necessarily require a specific collection and treatment, but don't forget that actually it's a coffee collection, not an aluminium collection, because 2/3 of the weight is coffee. And if you put the capsule into the yellow bag, for example, then the coffee is lost. And you have also the organic matter still on the aluminium, which reduces then the quality of the recycled material. And with a dedicated collection, you can increase the quality that you get. And you can also recover then the coffee grounds back, which is really then perfect, because then you close the loop for coffee and for aluminium.
Thank you, Marianne. And leading on from that, somebody else is asking, are you working on establishing a closed loop from capsule to capsule system? And if so, what is the current status of this?
So yes, we want to have more recycled content in the capsule, but this is a technical thing. And we are currently in Austria have established a new recycling process with pyrolysis, where we really get all the colors of the capsule, and we don't have any organic matter on the aluminium. I think this is then a perfect start for a capsule-to-capsule process. But this is currently ongoing because we have this pilot in Upper Austria where we collect all the different capsule types, sort them in a new treatment plant, and then we can do tests with universities to see if we can make a capsule 100% out of recycled capsules. This is currently ongoing in Austria.
Thank you, Marianne. And we have a question for Seamus, which is, how does the purity of the recycled aluminium compare with primary or virgin aluminium?
Mm-hmm. Yeah, we source our external primary aluminium from different sources, and then of course have different requirements to meet the expectations of our customers and the products that they want. So in that respect, primary is the characteristics are quite clear. And I talked a lot about recycling then, and our approach to recycling, and it also depends then, of course, on the makeup of the recycling material that we're using. But here we can then add different alloying elements to meet the characteristics of the product. So it's not so much on the purity, but rather the characteristics for each of the different alloys. That's the most important part for us.
Thank you, Seamus. And we have another question for Martin, asking about pinholes in thin aluminium foils in laminates. And does the portion of recycled aluminium in the foil affect this? And what are the effects on barrier performance?
Yeah, pinholes in thin foils, they are existing. Yeah, pinholes are existing in thin foil, and for sure, if you're using recycled aluminium, the pinhole amount will increase. If it is post-industrial, yeah, I think this doesn't really matter. But if it comes to post-consumer recycled content, then it will not work at the moment for thin foil. And this is what I tried to explain before. When we are going for low carbon aluminium, yeah, when it's thin foil, yeah, the majority or basically all of it will come from renewable energy, yeah. And when it comes to thicker specifications, to container material, there you will also have recycled content, yeah. So both will play together, yeah. But for thin foil, it's basically green energy, yeah, primary aluminium with green energy because of the pinholes which will occur when you use the recycled content, and they will not occur for thicker gauges.
Thank you, Martin. And another question for you we had. Can Constantia Flexibles already replace PT aluminium PE foil with the EcoAlu solution that is easy to sort and recycle?
The polyester aluminium PE structure is basically a pouch structure, and for this we have no commercial available solution, yeah, just for wrapping applications. We are in development of such specifications, but it's not yet commercially available. Like I said before, just non-sealable for wrapping applications.
Thank you, Martin. And somebody else is asking, this is another question for you, I think. On one of the last slides, you showed your CFlex sustainability roadmap with future goals for Constantia Flexibles. And which one of these are already available as a product today?
When you look at the roadmap, everything which is short term is available. This is reducing the material gauges, yeah, the thicknesses of the material, the substrates and the coatings. Then it's available for specific applications, the substitutions of laminates to monomaterial structures, like I said before, for wrapping applications. Low carbon aluminium is available, and also recycled content for thicker material gauges, for containers, for capsules. And what was mentioned on the right-hand side on reducing the carbon emissions for primary aluminum further than just green electricity for the electrolysis. This means inert anodes and so on. This is not available because this is everything in pilot and development at also our upstream suppliers.
Thank you, Martin. And we have another question for Seamus, which is if we use renewable energy, are we still talking about 4 tons of CO2 per ton of aluminium?
Yeah, this is one point that I mentioned as a key opportunity then to reduce the overall CO2 emissions. And I think, again, clearly reflected in Martin's slide that that's a key driver, so to speak, to reach that, the magic 4.0 CO2 number for, low carbon aluminium.
Thank you, Seamus. And I think we've got time for a few more questions. One question we had from Martin is on the last slide of where you talk about moving from aluminium paper to aluminium plus aluminium. Will this use adhesive, or how will you produce this?
Yes, it will use an adhesive. Yeah, it's a lamination. Yeah, of 2 foil layers with an adhesive. But this adhesive will not influence the recyclability, but it's for sure necessary to glue the 2 layers together.
Great, thank you. And yes, another question for Marianne. How much recycled aluminium is used within the Nespresso capsules? Do you also use quality from recycling streams, or is it from private collections only?
So the aluminium capsules is made with minimum 80% recycled content. I don't have the specific distribution to the both, where it's coming from. It's 80% recycled content.
Great, thank you. And I think time for one more question for Martin, I think. How does recycling work with a multi-layer foil with this eco aluminium?
This is a little bit a short question.
Yes, I'm kind of slightly trying to interpret this. I think it's about how you recycle a multi-layer foil using he writes eco alu, but I guess he means
So
recycled.
you mean the eco alulam? Yeah.
Yeah.
Now basically it can be recycled the same way like a container or a foil-based die-cut lid. Yeah, it's an aluminium which is coated. Yeah, in this case it's less coated because there is not really a heat seal lacquer on it at the current specifications, but you have a certain adhesive in the middle. But basically this can be recycled in the aluminium stream. Yeah.
Great, thank you. And time for just one more question, I think. Is the PVC-free and corrosion-resistant HSL for alu membranes available? I think that might be for you, Martin, as well.
It depends on the application. Basically, where currently most of the heat seal lacquers are chlorine-free. Yeah, let's put it that way. PVC-free. PVC-free they are all because this is so-called vinyl chloride. I have a certain problem now. Copolymers, yeah, and this is not PVC, but it contains chlorine, yeah. And currently, most of the heat seal lacquers are already free from chlorine, except special applications where you have a lot of corrosive ingredients in the food, like cheese specifications, for instance. Yeah, and here it's in development to transform also to substitute the chlorine-containing lacquers against chlorine-free lacquers.
Great, thank you very much, Martin. So yeah, that's unfortunately all we have time for today, but yeah, feel free to reach out to our speakers. I'm sure they'll be happy to continue the discussion offline or in a different space. So yeah, that just leaves me to say thank you everybody for joining us. This webinar will be available on demand within the next couple of days, and you'll be sent a link to access it in case you want to recap on anything you've seen in today's session. So yeah, I'd just like to thank our speakers again for sharing their insights today. It's been a really great webinar. So that's Dr. Martin Konfeld, Marianne Neumüller-Klapper, and Seamus Donovan. Thank you very much, all three of you, and thank you for listening and tuning in, everybody. Goodbye.